All right, last type with a greater than 1. Remember, if your leading coefficient was negative, so like if I had changed this one to a negative number, where that leading coefficient was negative, you would have to factor out a -1 first. Your leading coefficient has to be positive for you to be able to factor it. Okay? Anyways, so this time, the last pattern we're going to see is we have a -b but a positive c. Okay, so it multiplies to be a positive number but adds to be a negative number. Okay, so that's what we've been doing. And all of this multiplies to be 6 but adds to be 5. Multiplies to be -60 but adds to be 11. Multiplies to be -24 but adds to be -5. So that's what we're doing. What multiplies to be the c term but adds to be the b term. Okay, so write it up here. Let's do that. What multiplies to the b but adds, let's try that again. Multiplies to c. Jeez. And adds to the b. All right. So GCFs first. Okay. Nothing on this one, so I've got 5 times 6. Factor pairs. All right, so multiplies to be a positive number, but adds to be a negative number. How is it possible to get positive when I add, but negative when I, positive when I multiply, but negative when I add? So that's when both factors are negative. Okay, so which pair adds together be -17? That's -2 and -15. So -2x, -15x, bring down that 6 and the 5x squared. Group GCF. GCF again. Oh, whoops. That should be negative. (5x minus 2). X minus 3. All right, 3n squared minus 11n plus 10, no GCF. Multiply leading coefficient by the constant. So I've already done all these. I know it's 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Everything negative. Multiplies to be positive 30, but adds to be -11. And that's going to be -5 and -6 this time. Group, first two and last two. GCF of the first group. GCF of the second group. Common binomial. And whatever is left. All right, 8x squared minus 10x plus 3. No GCF. Always look for that first. Leading coefficient by the constant. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, both negative because it multiplies to be positive, but adds to be -10. Okay, that's going to be the -4 and the -6. One thing to be aware of, and it doesn't change your answer, is that you can switch these two, put the -6x and then the -4x. It doesn't matter. The order of the factors does not matter. So like on this one I did up here, on this one, I could switch it and have the x minus 3 first and the 5x minus 2 second. It's still the same as what I have. Multiplication can be done in any order, so it really doesn't matter the order of the factors as long as they're both there. Group the first two and the last two. GCF. GCF. 2x minus 1. 4x minus 3. All right, and our last one. This one does have a GCF. These are all even, so I know I can factor out a 2. All right, this one's a special one. It's a perfect square trinomial, but I'll show you that in a minute. So multiply the leading coefficient by the constant, ignoring that 2. Let's see, it's going to be 1 and 16, 2 and 8, 4 and 4. So what multiplies to be positive 16 but adds to be negative 8? And that's going to be your negative 4 and your negative 4. All right, let's see. Oh, GCF, first group. Second group. Common binomial. And then what's left. All right, so 4x minus 1 times 4x minus 1. This is a binomial that you have 2 of them. It has a multiplicity. Okay, so I write it like that. Okay, because it's this factor times that factor. They're the same factor, so it's a squared factor. And then you bring down your 2. And the way that I can tell it's what's called a perfect square trinomial, and I'm not going to test over this, just know it. It's helpful to know, I should say. Your first and last terms are squares, okay, which means your factors will be a square.